Hello everybody and welcome back. So in this next lesson we're going to be talking about startup scripts. So this is another context of applying Python within Houdini, but now that we've been doing a lot of Python sort of just directly in Houdini and kind of the on the go type Python, now let's do some stuff where we're actually laying down scripts that we're going to be using all the time. So we're going to be stepping a little bit outside of Houdini itself into the scripts that run to get Houdini going. And in order to do this, we're also going to be doing them in PyCharm, our external kind of script editor, right? It's just a nice way of writing script that helps you. So we're going to be sort of tentatively just starting with a little bit of that, which will help build us up if you've never used it before. And just talking about these startup scripts that run at the beginning of Houdini, either when the actual session is opened or when you open an actual scene file. So there are two scripts that run at essentially the startup. And what we can do is we can build whatever we want into these so that every time we open Houdini or every time we load a new scene, we can do something. Okay. Now, a lot of the time this is particularly aimed at pipeline stuff. So a lot of the examples are a little bit arbitrary because you could make them do anything, but a lot of the time when you want a blank scene, you just want a blank scene. But you'll normally want to maybe create certain variables or things like that. So we will kind of touch on startup scripts now, and I'm going to show you how to work with them. But later we may sort of need to come back and actually alter it as we build the pipeline tools at the end of this course, because then it is a little bit more relevant. So, okay, so let's get started. I have a basic scene here open in Houdini just for test purposes, right? And don't forget, I've got my little Python shell open here so that I can have anything printed here, right? And then I'm also going to be opening PyCharm. Okay, so in the previous lesson we had this installed, so I hope you all have it ready to go. And when we open it up, okay, you may not have a bunch of scripts and stuff that you've already been running, but either way, you can just say open, right? Because what we're going to be doing is we're going to be opening a script location as a project, right? You can go the route of saying create new project and then point to this file location as well, but then it's going to want to create a whole bunch of additional files that we don't really need, because we're just creating two separate scripts that Houdini itself actually reads. Later on, when we create our own scripts, then yes, we'll want to create a proper project. Now, let's talk first about the location where these scripts are stored. So let's go to the help and do about Houdini. And then we just say show details. Okay. And in here, like I said before, we've got a lot of variables and information. But the main thing we're looking for here is in our Houdini variables. So Houdini user preference directory. This is where we're looking for, because this is where Houdini is going to look for the startup scripts and any other of your sort of user preferences. Now, please note that it is specific to a Houdini version. So when you do version up, you'll need to kind of copy your user preferences from one version to another. But it normally is just in major increments, so it'll be 17 and then 17.5 and then 18. It doesn't go like in micro kind of versions. So at least you don't have to do it a million times, and you can just copy them. Right, so, like I say, it doesn't matter which version you're in, but just for this duration of this course, I'm using 17.0 at the moment. If you, whatever you're using, just substitute it for this, because don't go and create your scripts in 17.0 if you're using 17.5 or something, because then it's clearly not going to work, right? Okay, so that's where we're going to be going and having a look. So let's close this for now and open up here. So we're going to click open, and then we're going to go navigate to that path. So I kind of just have it over here in my clipboard. Come on, there we are. So we go to that location, and in that location you're going to find that we have a scripts folder. If you don't have a scripts folder, you can create it, but it must be named scripts like this, all lowercase. But I do believe that it should be there automatically. Actually, no, maybe it isn't. If I look at my 16.5, it doesn't seem to be there. So yes, you may have to create a directory over here. You can just create a new folder called scripts, all lowercase, right? So in here, this has this because I already initialized this as a project, but your new script folder will obviously be empty, but that's fine. So you don't need to create anything else in there, just scripts folder. And then with that selected, we're going to say OK, right? So now PyCharm is basically going to go load that as a project. Also, PyCharm always has this tip of the day. You can switch it off if you like, but honestly, there are so many cool features in PyCharm, all the little things that it does to help you code really quickly. So I always leave it on, and I like to learn something every day. So when we open PyCharm, you'll see on the left here, we've got this panel, and this is where all of your sort of files and paths and stuff live, okay, within your project. So we're going to be, referencing all of our scripts over here. And then in the middle is where we then write our scripts. Now at the moment we don't have any scripts, we just have a project folder, but we can create a script in here. So we can right click on the folder and say new, and then we can create a Python file, right? Now you can just create a normal file, and as long as you end it with .py, then it will become a Python file. Also, you don't have to do it through PyCharm. You could go just to your Windows Explorer, create a new text document, and as long as you name it with .py at the end instead of .txt, then it will be a Python file. Okay, but this is a nice, easy way to create one. So we're going to just go and create a Python file, and it's going to ask us for a name. Now, the names for the two scripts are 123.py and 456.py. These are not optional. You can't name it whatever you want. These Houdini is specifically looking for this name, so you need to give it these names. 123 runs whenever Houdini is launched. 456 runs whenever we load a scene, which includes an empty scene. So when you launch Houdini, it runs 123 and it runs 456. But then when we say file open and navigate to a file, or we say file new and we load just a new blank scene, either way it will run 456 but not 123. Okay, 123 only runs once when Houdini is launched. Okay. Alright, so we're going to create a 123.py. Okay, so let's do that. And in fact, while we're at it, why don't we go and create the 456? We might as well. So 456.py. Okay. You may not need to put .py at the end. Maybe if we just said 456, because we're saying file new, create a new Python script, it will probably add the py for us. But I don't know. Sometimes I'm a bit pedantic, and I like to make sure that it definitely is going to be working. So these two scripts are going to run at those certain times when we load Houdini, right? And they will be picked up from this directory automatically, because this is exactly where our Houdini preferences directory is pointing. So we should be able to now go and, let's say, for example, we want to, in our 456, let's just say print hello. Okay. So, and actually, let's put something here. Print hi. Okay. So when we load a new scene, it should just say hello. But when we launch Houdini, it should say hi and then hello as well. Okay. So let's try that out. So if I just click here and say file new, you'll see that it says hello in the Python shell. And again, if this was not open, the Python shell, you're not going to see this. So always please have a Python shell open and not compressed. Otherwise it will not print to it. It only prints to it when it is actually physically open. So make it as small as you can. And then when you want to, you can sort of expand it and see what has been printed, because it'll at least keep a record of what you've done. Right, so you see it only said hello because it only ran 456. But if I close it and then open a new one, well, in fact, I'm just going to right click and open a brand new Houdini over here. you see it even prints it to the console, which pops up first because it doesn't have the Python shell. It says hi and hello. Now, unfortunately, if it prints to this console, then it kind of neglects to print it to the Python shell. But either way, this is just proof that the scripts are actually working. Okay. If you're not getting this, then you may have gone wrong somewhere with something like, are you in the right user preferences directory? So specifically check if you go help and about Houdini and expand this, double check that you're in the correct directory and that your scripts are named correct, 123.py, 456.py in a folder called lowercase scripts. Okay, so that should be easy and should work. All right. So we're going to start with kind of the most basic one, which is going to be, we're going to set up a little startup scene, I guess. So we're going to use our 456.py. Now, I just want to kind of give you some advice here, or a little bit of insight. More often than not, I find that I'm using 123 for most things, because a lot of the time it just, you know, when you open a scene, you don't know what's in that scene. It could be a test scene, it could be a shot that you're working on, a brand new asset, it could be literally anything. So to know what, I haven't really come across very many useful things to put in a 456.py, because it kind of depends on what scene you're loading, right? So maybe you can think of something, and of course, if you ever want something to happen every time you load a new scene, then great, that is what this is designed for. But a lot of the time I find that I'm leaving this one empty, because there's nothing that I really feel the need to trigger every time I have a new scene. But whenever Houdini opens, that's a very powerful one, because, well, especially for pipeline, because a lot of the time you want to initialize certain variables or something like that. Okay. Now you could build your pipeline around every time you load a scene, it then checks which project folder you're in and then creates a bunch of variables based on that. So 456 could be useful in that respect. But we're actually going to handle our pipeline variables a little bit differently later on. You'll see we're going to be using an HDA to kind of trigger that. And so the callback from 456 again is a little bit redundant. But it all depends on how you've set up your scene. So I just want you to know what this is for, and we're going to build a cool little example in here, but really in real world, I often end up with this blank, but then my 123 is setting up a whole bunch of variables, paths, and like scan paths and things, which we're going to do. I'm going to show you now how to do something very useful with 123. But let's start with 456, because it's something a little bit simple, right? So what I want to do here is I want to start every blank scene that I have in Houdini with just with a grid, just like basically a ground plane. Okay, so I just want some sort of ground plane, not maybe named correctly. Maybe we'll give it a color or something. And so I essentially just want that, but I only want to do that if I'm starting a blank scene. Okay, so as I said before, and we've been working through how to create a script, when you describe what it is that you want to do, the words that you choose, you should actually maybe record yourself saying it, because a lot of the time, literally the steps you use to construct that sentence in English is what you need to do step by step when creating the code. Okay. So the first thing we want to do is make sure that what we're opening is a blank scene, and not, if I go file open and go and open maybe the scene we were working on in the previous lessons or something. If I open that, I don't want to now suddenly every time I've opened the scene, I've got a new grid like chucked into the middle of the scene. That's bad. But if we've got a blank scene, then we say, well, let's start with a ground plane. Okay. So how do we check that? Well, there is a very useful module that we're going to want to use, and we will be using this a lot later as well, so it's worth having a look at the module. In fact, let's open up the help file for it. Right, so this module is the who.hip file module. Okay, So it's a submodule of the Houdini module, but it is a hip file module. Okay, now this contains a bunch of functions and classes that have to do with essentially just our scene file. Where is our hip saved? What is the name of our hip? Like, what is the path? Do we have unsaved changes? You know, so like, has stuff been changed, or have I only just opened it or just saved it, right? And we can save a backup, and we can do a whole bunch of things, right? So what we're looking in here to do is actually just find a way to ask whether we've saved our scene ever or not, okay? And one of the easiest ways to do that is to just look at the base name, because what is the base name of my current file? Right, now the base name is essentially just the name without the path, like just the file name portion of it, okay? So that's here, untitled.hip. But if I had saved it, of course I'm not going to call it untitled, right? So, you know, that's our way of checking, okay, has the scene ever been saved? Okay. We could do other things as well. If we wanted to be really careful and cautious, we could double check that there's nothing else in the scene, because maybe I have created some things but then saved it deliberately as untitled.hip, which seems a bit weird. Who would name that? If you're out there and you're doing that, please don't name your files untitled.hip. It's the same as never ever name your files with the word final, because nothing is ever final. I see people with final, and then final version 2, and then final, and then absolutely final, and then there's still another version after that. Just nothing is ever final, and please, nothing is ever untitled. So let's check our hip name. So I like to do a lot of tests in the Python shell before we actually move it to our main script, because one thing you need to know, the sort of autocomplete, so when we type who dot and it has this nice drop down, right? That does not work properly in PyCharm, right? You need to set up the Python interpreter so it will actually look and load the Houdini module. It is possible to do. There's a lot of steps to it. I can't even remember it, because I just gave up doing it at some point, because it wasn't even worth it. Because even when it was working, it would only work on certain modules but not others. It's a bit strange. So because obviously it's a module that is designed specifically to work within Houdini, and so a lot of information it can't seem to kind of pass out into PyCharm. So I basically try to test lines of code in here and then just move them over when I know that it's working. Okay, so we go who dot, and then we're going to go reference our hip file module, and then we're going to grab our base name function and run that, and you see that gives us untitled.hip. Now it's important to note that it gives us the actual .hip, but this could be, depending on whether you've got commercial or indie or whatever, or you know, the non-commercial free version, this may be different. Now I'm using indie and it says .hip, so I guess when it's brand new and blank, it hasn't saved yet, so it hasn't figured out whether it is an actual .hip or a .hip LC or hip NC. But either way, I don't really trust this, because what if they suddenly change it and figure out that, okay, hang on, maybe we should have it, even the untitled blank scene now has the sort of the version of Houdini at the end, so hip, limited, commercial, or non-commercial, right? If they change their mind in the next version, I don't want to have to recode my things. So I'm always cautious about relying on certain information that is coming from other sources, okay? But the one thing we can be certain of is that it will always be called untitled. So let's grab our base name, but let's also strip away this at the end and leave ourselves just with untitled, and then check whether that does equal untitled. Now, how do we strip that away? Well, let's store this in a variable quick. So let's just say x equals. So we just have it stored. And now let's pull that away. So we've worked with strings before. So there are a few ways we could do this. We can also see if X starts with untitled. So that would be true here. But I prefer, because I'm always a little bit weary of this, maybe it starts with the word untitled, but it keeps going and it's actually some weird save, you know, I don't know. I prefer to go maybe the route of saying X dot, and then let's split this string. And we're going to split it by the dot. Okay, so we can't just use a normal split because it's not a blank space, it's a dot. So we're just going to give split dot. And what that's going to give us is a list where we've got untitled and hip. So if we grab that list and go 0, so grab the first index, we've now stripped away and got nothing but the word untitled. And now we can compare and say, is that equal to the word untitled? And because you can compare strings like that, we now, when we do that, it says true. Okay, so now we've tested the function that we want to do. Let's go back into PyCharm and put that into practice. Right, so in here, we're going to just start typing. And again, at the top, you import any modules that you want to have access to. But remember, I always import the Who module. Well, in here, it's not useful. It doesn't know what the Houdini module is, and it's going to complain about it, right? So we're just going to start typing. But if we do want any other modules, we'll import them at the top. Okay. So the first thing we're doing now is to check. So we're going to say who.hipfile.base name. So that's the thing that we did before. But we don't have to store this in a variable since we're not going to reference it again. We're just checking whether this is untitled. So we can do everything that we just did in one line. So now we can dot split it. But remember, we're going to split by the actual dot sign. And then we're going to be grabbing the first index of that and comparing it to just the static string untitled. Okay. Now you'll see PyCharm does a lot of things, for example, highlighting references that it doesn't know about. So obviously you're going to see who is going to be underlined every time. Just ignore that. Okay. PyCharm can't run the Houdini module, but when Houdini runs the script, it can load the Houdini module, and so it will be fine. So you can ignore that error. But it will also do things like highlight full sentences where, well, full lines of code where this is not complete. It's kind of erroring or warning us, saying, whoa, something here doesn't seem right. That's because we haven't done anything with this. We're not storing it in a variable, or we haven't put it inside of a block statement. So what we're going to do is put this inside of an if. So if this, and then we put a colon at the end, right? Now you'll see when we hit enter, it even tabs in automatically for us. So this is great. You know, this is why I love working with PyCharm. Also, if you're anywhere within the line somewhere, like a lot of the time when you start typing this, for example, let's just go back here. When I put the first quote to type the word untitled, it actually puts the second one and puts my cursor in the middle. So now I can type the word untitled and it's already got the quote at the end. But also from here, if I want to now skip to the next line, I don't have to move to the end and then hit enter. If you just go shift enter, it actually just jumps to the next line and leaves everything as is. Okay, so this is some really useful shortcuts in here. So now what are we going to do with this? So we want to create a grid inside of a geometry node. Let's do it. This is something I want you to sort of get into the habit of doing. So let's physically do what we want it to do. So we're going to create a geometry node. We're going to call it ground, or ground plane, or whatever you want to call it. We're going to dive inside. We're going to create a grid. Let's, because we don't really want all this geometry, so let's go and set the actual rows and columns down to 2, so we literally just have a plain grid, just a square essentially. And let's create a color node and make this kind of blue something, right? And obviously set the display and render flag to that node. Okay, so this is essentially what we want to do, is start our scene like this. Okay, so let's do that. Let's follow those steps, but in code, right? Now, if you want, you can code it directly in PyCharm here. If you're still feeling a little bit unsure, maybe the best thing to do is actually type it in Houdini inside of the Python source editor. And when you can click apply and it works, then we just transfer that to the if block. So let's do it that way. Later on, we're probably going to move over and just start doing a lot of coding directly in PyCharm. You can obviously always just do it in here and move it over if you prefer. But later, as I'm going to assume that we're getting more practiced and better with it. But for now, we'll start with the most basic way of doing it in here. Right? So we want to create a node, a geometry node. So the first thing we're going to do is reference the obj node, remember, because we can only create nodes inside of other nodes. And so we're going to create a node in here, and the type is geometry. But, well, the type is geo. But we also want to give this a name, and instead of having to give it a name, there is already an argument for the name. Remember, it's the second argument. If you haven't remembered, let's open up the help file and just go and check who.node class. Go grab the create node, and you'll see there node name. Right? So if we give it a node name, so let's call it ground. Okay. Now it will create that. Okay. But we also want to do other things to that node, and it's going to return the node. So let's store it in a variable. So we'll just call that variable ground, so that makes sense. Okay. So if we click apply, it's going to create that. But this is empty. So inside of that node, we want to create another node. So we're going to say ground.create node. And this time, what we're creating is a grid. Now, we're just assuming here, but let's double check that the grid is literally just called grid, and it is. Okay. So we can say we're going to create a grid, and we can just leave that with node name because you know grid 1 is fine. And let's call this grid. Right? Let's store that in a variable 2. Because now on that grid we want to make some changes. So we want to say grid.palm, because remember we want to, well actually, let's disable this line for a second. Click apply and see that it worked. Now on the grid, we're wanting to change the rows and columns. So the rows is called rows, the column is called cols. Okay, so let's go and change those two to the value of 2. Remember, if we change it to 1, it becomes just a line, so you need at least 2 and 2 for it to be a square. So palm rows dot set, and then we're going to set it to 2, and we do the same thing with the cols. Right? So that should give us, if we just click apply, gives us a grid with 2. Okay. Now we want to create a node over here, a color node, and plug it in. Now I know we've done the long way, which I'm glad you guys know, the actually creating a new node with a reference, moving it to a new location, plugging it in, you know, set input and whatever. But I'm going to now teach you a slightly shorter way, which is not always relevant. That's why it's good to know the long way, but in this case it'll help us, is we can create an output node. It's basically just a shortcut function that has been created, which does a whole bunch of the things that we were doing, creating it, shifting it, plugging it in. Right, so let's have a look at this function so that we can tackle it. So it'll still be under create, but if you see here, there is create output node, and there's also create input node. But in this case, we're wanting to create a node that is plugged into the output of grid. So in other words, it's an output node. Right, so let's read this. So it tells us we need to give it the node type name of the new node, obviously. Okay, you'll see this will be very similar to create node. Then it asks for a node name, which also has a default of none. Run init scripts, load contents, and exact type name. So that's got the exact same functions as that. Okay, and although it doesn't say it, it should probably return. maybe I haven't actually checked, but maybe it does, or maybe it doesn't return a reference to that output node. In fact, I believe it does. So we'll double check that. Let's make sure. But if it doesn't, then that's actually bad that they haven't included it here, because it should have that arrow and say return who.node, right? Okay. Oh, you see here, it does say return the new node, but they should have put it here. So it's unfortunate that sometimes you can't rely on it. It should say this, but that's unfortunate. Okay. So we're going to create this output node. And obviously it's then going to plug it in, but it's going to connect it to its first input, right? So, and first output. So if we ever wanted it to connect it differently, we couldn't just use this create output node. So there are certain contexts where this won't work. Let's do this here now. So because we're going to create an output node of the grid, what we do is we run it on the grid. Okay, so we're not actually running it on the ground node and saying create a node inside of you, so create a new child. Instead, we're saying here create a new output. Okay, so we apply it to the grid, not the geo node. So we say grid.create output node. Then we give it the type, which is, let's double check it, middle click, color, spelled the American way. So color, we don't need to give it a name, we don't need to give it any of that other information, but let's store our name, well, a reference to that new node there. Okay, so let's delete this and click apply. It does that, and you'll see here it has created a new node, a color node, and plugged it in, which is great. Okay. But we want to go and move our display and render flag, and we want to go and set this color to maybe that. So 0.25 and 0.5. Okay, let's do that. So here we would say, okay, we want to set the generic flag display and render to the color node. So we want to call the color node color dot, and then we say set generic flag. Remember this from the previous example. So the type is who.nodeFlag dot display with a capital, and the value we want to set is true, or you could put a 1 if you want to, right? And then over here we can just copy paste that and swap this for render. Okay, so that is quite simple. In fact, let's test that. Let's delete, click apply. All right, so now it's set to color. And the only other thing left is to say color dot, but now instead of referencing each parm, let's reference the parm tuple. So I'll show you the reason why we would want to reference tuples instead. So we reference the tuple. Now the tuple would be called color. C-O-L-O-R, not with the double R at the end or the G or the B, right? So color ending with RGB is the actual component parameters. But we want to reference the entire tuple itself. Okay, so we just drop that component index and use parm tuple here instead of parm. And now what we can do on parm tuple, you can still set it. Okay, there is still a set function on parm tuple, right? Let's find our who.parm class. Who.parm tuple class. Now on the parm tuple, you'll find, okay, we can scroll down, but let's just search for it in here. There is a way of setting it, but it will explain here that you just need to specifically, if it is a tuple with t, x, y, z, then you need to give it a tuple of 3 values, right? So it's a quicker way, instead of us having to have multiple lines and we reference color R, color G, color B, let's just say reference color and set it to the value of a tuple. And remember our value was 0.25 and 0.5, I think. 0.25 and 0.5, yes. So that's the one we wanted to set it to, and we'll finish in brackets. So remember, this needs to be a tuple. It could be a list as well. You can give it square brackets if you want, but normally if you're using it only once, we use a tuple. The only reason you want a list is if you're going to actually be appending or removing or altering that list in any way. Right, so let's delete our current node over here. And when we hit apply, we should end up with ground, a grid inside of that, 2 rows, 2 columns, and a color, blue color with the render and display flag there. Perfect. So now this script is what we're wanting to trigger when the base name of our HIP file is untitled. Okay. Right. So that's what we're going to put in there. And maybe for the sake of it, let's just put in an else and say, otherwise, if it's not untitled, if it's something else, then just print, I don't know, work hard. Because you're working with a scene that you've already been working on, so clearly you're continuing. So we'll put some encouragement there for ourselves. All right. So now don't worry about any errors in here with the Houdini. That's the only ones. But PyCharm will normally point out any other syntax errors, so look out for them. But you can ignore the Houdini ones because this is something we know. Okay, so that's in our 456. So when we load a new scene, okay, blank scene, let's say file new, and look at what has just happened. We've got a ground and color and everything's working perfectly. That's great. Now if we go and load maybe an older scene like the test that we did the other day, look, it prints saying work hard, but it does not create a grid for us. Okay, and you need to be careful of that because it will, if we didn't put this first bit, it would actually be creating it every time we load a scene, and that includes when we load it again and load it again. It's just going to every single time add a new grid, a new grid, a new grid. Okay. All right. So new scene, and you see there we start with a grid. Okay. So now let's move on to our 123.py, and this is where we're going to be doing stuff that is a little bit more relevant later on, but also it gets a little bit more complicated. So this is, we're sort of laying down the pipeline here for our pipeline tools later on. Now something I want to talk about is the sys module. So there is a new module that we haven't spoken about yet, and that is sys. Okay, so let's just create an extra space here, and we're going to say import sys. Okay. So this is a module. If we just type sys, you'll see there, it's a built-in module. And there's a cool way, if we just type help sys, then it's going to pop up with some information about this module, right? It's going to tell you about the functions and other classes within the module. So there we go, a list of functions and static objects. And it gives you a description here, tells you the name, so it gives you lots of information. Also shows you where you can go and actually look for that module. Okay, and it's important here to understand what this is doing. So this module provides access to some objects used or maintained by the interpreter, that's the Python interpreter, and to functions that interact strongly with the interpreter, right? So it's essentially a module that is giving extra information to assist Python with what it needs to do or where it needs to look. And what we're going to be doing is using this. There's a sys.path, okay, which should be over here. So it'll be under data. There is a list inside of sys.path of paths, locations where it looks for packages. Okay, where it looks for scripts essentially. Now, we already added our location that we wanted to search for scripts to our environment variables, right? So remember, we created this Houdini, like _Houdini, this global area, and we created the scripts folder, right? Yours will be empty at the moment, but we referenced this in our environment variables on our computers so that it would be added automatically. Okay, and if I type sys.path, it's going to print the whole list, right? And in fact, because that's all printed in one go, let me see if I go here and, let's go import. So remember I showed you pretty print. So we're going to say from pprint, import pprint. So we just want the pprint function from the pprint module. We're going to actually pprint sys.path. So that prints it nice in order. It's just easier to now read. Okay, so this shows us where all of the packages are. And because we added this to our environment variables, it is now automatically added to this. Okay. But I just want to point out, and we're going to use the 123 module to essentially, well, the 123 script to add packages to this sys.path. The reason being, it's nice to have an alternate. So instead of adding it to the environment variables, there might be a better way. For example, if maybe you want to build your pipeline where you just in the user preferences folder you initialize the packages, and you don't want to have to actually alter the environment variables of the machine. Or you just want to, on the fly, you sort of want to add stuff. So if we're busy working and we create a new module here, so we go and create some new script, and it's saved on maybe even it's saved on your desktop. Please don't work on your desktop. Like please do not work on your desktop. But let's say we created a new script somewhere, I don't know, in my documents folder. And we just want to be able to import that. Right, now if we just go, let's say it's called my script, we're just going to say import my script, and it's going to go, I don't know where the heck that is. We need to say sys.path.append, and we append to that path the location where our my script lives. And then when we say import, this is Python's going to go look in all of these locations for scripts, including now, once we've added that location in my documents to this, it will find our script and import it correctly. Okay. So very important to understand how this works, because we will be using it in the pipeline stuff. And also if you're ever wondering, how do I reference a script that's now saved somewhere else? This is how we do it. And it's also good to know that we can remove stuff from these lists if we want to say, every time we change to a new scene, we actually want to remove packages from other projects to keep our stuff clear. You don't want to use scripts from other clients, because you could have maybe two different clients and they both have some initialized script, and maybe they're named the same thing. And you don't want to load one and then you just go file open and move to another project from a different client, and suddenly your scripts are conflicting. So that's the type of stuff we're talking about here. So it's important to understand what the sys module does. Right, so what we're going to do here is, I know it's a little bit redundant because we already have that file in that path to our scripts inside of our sys.path. But let's add it using 123.py anyway, just so that we know it's independent of our environment variables. Okay. But what I also want to do is allow myself to sort of have some flexibility. If I want to go later and add a new location where I say, okay, well, maybe I've downloaded some other packages from someone. Maybe I find some cool Python scripts that someone's developed for Houdini online, and I want to store those, but I want to store them maybe not mixed up with my own scripts. So I want the ability to go and add more locations, just keep adding, and know that Python will just automatically grab those new locations and add them in. Okay. So we're going to create a list of locations and then import them or append them to sys.path. So the first thing we're going to do, of course, is specifically we need to import the sys module. Now when we do, you'll see PyCharm makes it gray because it's saying this is redundant. In fact, let's hover over it. It says unused import statement, because we've imported it, but we have not called the sys module once. This is trying to optimize our script for us later if we've imported a whole bunch of modules, but maybe removed a few lines of code, and at the end it goes, hey, you're importing this, but you're not actually using it. It'll allow us to clean up. But as soon as we call it sys, then you'll see it stops being gray. So let's create a list of of locations where we want to append, because what we're going to do is say sys.path.append, but then we want to loop through a list and add our paths. So we want to add a path, right? But let's, to avoid conflict over here, because this is called path, so we don't want to confuse ourselves, let's just call it P. So we're gonna inside of a loop, we're gonna add each path to sys.path.append and put it into this function. So we're gonna loop through, so we're gonna say for P in, but we need a list. So let's just create one called import list. Okay, and we're gonna loop through that list, adding P to this. So of course we need to create that list before we can loop through it. So we say import list like that equals, and now when we hit the square brackets over here, now we're not going to be giving it just an empty list, although if you have nothing to append to it yet, then of course you can give it an import list, an empty list, because it's just going to not loop at all, right? So this will be fine, it won't break. But when we, and particularly in PyCharm, when I am typing long lists, you kind of want, you don't want to have like, something, comma, something. This is very hard to read, okay? Everything in one line. And also you'll see there's this line over here where basically PyCharm is saying you shouldn't type scripts that have lines that go beyond here. If you reach this point, you should actually enter and split it into multiple lines, because people can't easily read really giant scripts, okay, like in one long line. So instead of doing it this way, what I prefer to do is split each entry into this list onto a new line. Now PyCharm helps you format this correctly, so if we are inside of the square brackets, if we just hit enter, it goes and creates this formatting properly, where it has put this at the beginning, this over there, and then it's tabbed in over here, so we can start writing our list. And then this is so much more, so much easier to read. Okay, almost like when we did that pretty print of the list, you want everything under one another instead of in one giant big, just blob of text. All right, so the location that I'm pointing to is where we've chosen to save our scripts, remember? So that is in that, so here we go, I just have it in my clipboard, wherever you've saved yours. So that underscore Houdini folder. You didn't have to name it with underscore, by the way. I hope I mentioned that at the time, but it's just about creating a global location where we have all of our scripts for Houdini. And then later what we'll do is when we load each scene, depending on which client it's for, depending on which project it's for, we will also add other script locations to our sys.path. But not through 123, because 123, this is global. This is every time we open Houdini. It doesn't care which project we're in. So in this one, we want to load global locations. So maybe our global scripts, and maybe some, like I said, if we download some scripts that someone else has done, we could save them in a separate location, or maybe it's on a server somewhere. You just point to that location in this, and this is kind of the global import. And then later we're going to design some tools that every time we load a new project or a new scene file, it goes, which client is this for? Which project is this under? Okay, I'm going to go and add those paths to sys.path so that we can, when I'm loaded on the Rebelway project, I can load the Rebelway scripts. But the second I switch over to my own personal project, I don't have access to the Rebelway scripts. Okay. So we give that, and obviously we'd put a comma at the end and then move to the next line and then type some other location, right? So whatever, and we just keep going. Okay. And that's how you then can keep these nice and organized. You can just go and add in new locations, right? For now, we only have the one. Okay. And then we're going to loop through that, which, okay, it's only one, but still, it's going to work. Where then P is equal to this. And we're going to say sys.path.append and add that to this. Right. So let's make sure that this has worked. So we'll go and, in fact, to confirm that it has worked, let's go and specifically add a random new location that we know is not already in there. So I'm going to maybe follow most of this, but then inside of here, I'm going to just add something like that. Okay. So, because this doesn't actually exist, but I mean, sys.path doesn't care whether it exists or not. It's just appending strings to this long list of locations where it should try and check. If it finds the location doesn't exist, it'll just skip it. Okay. But if we find this now in our sys.path.append when we load a new Houdini scene, then we know that this has worked. Okay. So let's try that. So it's not going to happen when because it's not in our 456, it's not going to happen when we say new, right? So we go create a new scene, okay, and we go check our, come on, Python shell, where is it? Okay, for some weird reason, oh, here it is. We can just type sys.path and look for it. Well, let's, do we still have pretty print? Okay, yes we do. So we're going to pretty print our sys.path and see, and you'll see that there is that location, but that's because that was already there from our environment variables. You'll see that you don't see anything else in F drive, which is where we created that random whatever folder. Okay, so it has not worked on 456, but if we go right click here, open a brand new Houdini, now this will run 1, 2, 3. And when it does, it's going to append to sys.path. All right. It also runs 456. Don't forget that. But it runs 1, 2, 3 first. So let's go and open up a Python shell. Do we still keep pretty print? No. So we're going to have to say from pprint import pprint. And do we have sys? Yes. Okay. I think sys is automatically imported. So then we're going to go, not import, we're going to say pretty print sys.path. And here you'll now see, okay, we actually have, it has appended both because it actually, I mean, it's a list, we're appending, but it doesn't really matter if there are redundant, duplicates in here. It's still going to look in both locations. Okay. Well, it's just picking up which locations it needs to look through. Right, but it has added this to the list, so that means that our 1, 2, 3 script is working. Okay, now I'm going to just take this one away because I don't want that to be there, but this is good. Okay, now something else we're going to be adding to our 1, 2, 3 is HDAs. Now, I don't know if you've ever found it very kind of frustrating, but with HDAs, the scan path, you need to go and save it in a very specific location in Houdini, like in its locations. And it's very difficult to then go and like add. I find it's hard to find information about how to add additional paths like we just did with our scripts to sys.path. It's just like, how do I go and add another path where Houdini goes and scans for HDAs, right? So let me clarify and show you exactly how this works, because it's frustratingly under-documented. Okay. So if we go look for our $HH, okay, which is it's hard to tell whether we're on the right line. There we are. So this location, okay, but then /OTLs, okay, is our Houdini OTL scan path. Now there should, well, sometimes you'll find that there is a variable already created called Houdini OTL scan path, right? Now it is specifically called OTL scan path, not HDA. They've renamed OTLs to HDAs, but they haven't renamed the variable. So the folder is still called OTL, and the variable is still called Houdini OTL scan path. Okay. Now it isn't automatically created, but it does respect that variable. So if we do create it, it will look in those locations for OTLs. Okay. The one thing though is that it is automatically, because it's not here, it is defaulting to searching in HH/OTLs. So it's looking here in, program files, side effects, Houdini, and then the Houdini folder, and then inside of that it's looking for a folder called OTLs, right? So if we go and create a Houdini OTL scan path variable and tell it, to point to certain locations for it to go and scan, we need to add that HH/OTLs to it, because otherwise we will be pointing to our own custom location where we want HDAs to be scanned, but we'll then be bypassing all of the HDAs that are in the default location. And we don't want to do that. We want to work with both. Okay, we want it to scan its own default location and our location. Okay, so let's go and do that. So we're going to go and create an environment variable called Houdini OTL scan path. We're going to make sure that we have HH/OTLs in it, and then we're going to add another list of, just like this, just like our PyCharm list over here that we're looping through to add it. We're going to do that with HDA locations in here. So now we can choose a location where we saved a bunch of scripts, and we can add a bunch of locations where we've saved HDAs. And every time Houdini loads, it goes and adds all of our default locations. And in that way, it means we can have HDAs spread all about the place for different clients, different projects, stuff we've downloaded, and we just add it to this list, and it all loads nice and easily into Houdini instead of us having to go and put it in a very specific location. Okay. So we're going to do something similar here. We're going to be creating an HDA paths list. Okay. And in this list, what I'm going to do, you'll see that very similar to this location, okay, is I've gone and actually stored an HDA folder as well. Okay, so this HDA. Now, there are these HDAs which I've already created. We're going to be creating these later, but because this has not been added to our scan path, because Houdini OTL scan path does not exist, and this is not in $HH, it will not find these. So let's confirm that. Okay, so the one's called scene data, the other was called HDA ROP. Okay, so let's go and double check. If I go to my location over here, my scene, and try and load that, so scene data should be on this level. Okay, nothing. It's not finding it at all. Right, but let's go and add it in. So if we go, and it'll be in the same location. So actually I might even as well just copy this, except instead of being in scripts, it's in a folder that I've called HDA. Let's just double check. Yeah, HDA. Okay, so that's the folder where I am wanting it to scan. But then don't forget, we're also going to be adding $HH/OTLs to it. Okay, now what we can do, right, so let's just do it this way. We're going to say, in fact, let's go into Houdini. This is even better. So don't forget that when we want to create an environment variable, and we have mentioned this before, we can say who.getEnv, and we can look for something like, for example, HH. Okay, and it tells us where that location is. When we can also, and let's double check, let's look for, so it's called Houdini _ OTL scan, so one word, _ path, like that. Now this is returning nothing, that's why I printed nothing. But this is a very specific known variable. So we need to go and set that. Now how do we set an environment variable? Remember I said it's not set, it's who.put_env. Okay, so we're going to put the OTL scan path, and then we give it a value, so we can just say that it should be equal to foo. Okay, so now when we get, it will be foo, right? But that's not obviously what we want. Like, that's not what we want. So we want to set this through our script. Okay, but this is the method we're going to be using. So let's copy this. But instead of foo, what we want to do is give it a bunch of these locations. Okay, so in other words, all of the paths, right? But the paths, instead of having to go loop through and append, because this sys.path.append is a function that actually works and helps us just add those paths in. Here we need to construct this path. And if we want to construct multiple, so if it has more than one value, so it's got foo and something else, we can't just append to this. We're going to overwrite the whole value. And in order to store multiple, we have to have them separated by a semicolon. Okay, so you'll see that maybe there are some others that have lists stored as an example. I hope there are, so you can see. Well, see here, class path. See, it's got dot and then colon, like semicolon. It's got an additional line. So those are two different entries to this. Let's see if we can find one that's a little bit clearer, a little bit better. Here, okay, so path extensions. So it's got a whole list of them, and the list is semicolon separated. So that's what we need to do. Or in fact, path. This is a really good one, because this is exactly what we're talking about. We're going to be constructing a path that is separated by semicolons, exactly like our sys.path, which is also in a path variable. Okay, so this is what we want to do. So back in here, we're going to be joining our list of paths, and in fact, let's give it. So one of the paths is going to be $HH, okay? Because remember, we're wanting to call the variable, right? So it's $HH/OTLs and then slash. Okay, so this is the default location where it should be scanning already, and we don't want to override that that variable. We just want to add a new one to the list, but we need it to be semicolon separated. So we already have a list here. What we can do is use, if you guys remember, the join function. Okay, now join is a little bit is a little bit counterintuitive, like I said when we discussed it. You don't join, the list. You don't give it the list and say hdapaths.join, okay, and then give it a separator. It's the other way around. Okay, so we actually give it the separator, and on this string we're going to join a list using the separator. So we give it the semicolon, and then we say .join, and then we feed it our path here. So HDA paths. So we give it this list. Now it's going to loop through this list and join each one of them. So join that to that with a semicolon. Okay, and it's going to set that as the result, or the value for Houdini OTL scan path. Right. So let's check if that works. So this is going to run on 1, 2, 3. So remember, we need to go and actually open a new scene. Okay. So let's close this one and go and open a brand new one. So first of all, we'll be checking whether Houdini OTL scan path actually was created, and then whether it is set correctly. Okay. So it's gone and created that. And then we go here and go down, and let's see if it's created it. All right. So there we are, Houdini OTL scan path successfully created. It has $HH OTLs, and it has our location added to it. Right. Now let's see though, if I try and find scene data, you'll see that it's still not found it. Now why is that? Well, what happens with this 1, 2, 3? It runs at a very specific time in opening Houdini. Okay. And it basically runs too late. It runs after it does any scanning. Okay, so there is another script that we can add to, but it's an H script. It's not Python, and that one runs before the scan. So you can actually use that to add to your OTL scan path, but I don't like to separate it into, I've got to do some Python scripts and some H scripts all separated. It's very difficult to work with. So we just need to add one more step here, is, because essentially it's opening Houdini, it's then scanning the OTL paths, then it's running 1, 2, 3. So we're adding to the paths that it should scan, but we need to essentially kind of re-kick it off and say, hey, go scan these paths, right? So let's just do that. So there is another module that we're going to be talking about that does this, that can achieve this for us, okay? And that is the who.hda, okay? Not to be confused with the who and the HDA definition, okay? But the actual HDA module, right? Now let's see what this has in it. Okay, so you can do this, or you can open up the normal help file and see what's inside of here. But what we're looking for is essentially a function to tell it to scan the paths, all right? And there is a function called reload all files, or reload specific file if you want to. So if it gets really heavy, if you've got a load of things and you're just adding one path, what you could do is let it, because Houdini will already have scanned at the default location, you could actually separate this into 2 lists, take all your custom ones and loop through and scan those just manually so it doesn't scan this twice. But honestly, I haven't found that it slows it down at all, so we can just do that. So it is the who.hda module, and the function was just called reload all files. What that's going to do is essentially go and rescan again. But now, once it scans, because remember the first time it will have scanned the default location because we hadn't created this variable yet. 1, 2, 3 runs, it creates the variable, stores it with our custom location and the default. And now we say, go reload them again. So now it's going to find this, scan these paths, and load our HDAs. Okay, so let's go and close this again. Open up. And there we are. So now we have our grid and everything. Let's go and check whether we have the path correctly created. Houdini OTL scan path, it's got our 2 locations, and then when we type here scene data, there it is, and that's the HDA that we're going to be creating later on. Okay, so now you could easily go, once this is all set up, you can then just add paths here where you want to scan HDAs and add paths here where you want to scan scripts from, and this will run every time. But these will obviously run on every scene, so you don't want to do this with project-specific things. We will get to that later. Essentially, later on, we're going to be doing something very similar to what we just did here, adding to the path and reloading all files, but we're just doing it when we know what project we're in. So as we load the scene, we've got data about which client, which project, which things I should scan that are specific to what I'm working on, and then it will load those. Okay. And the reason I say this is because it depends on who you're working with, but some clients are very picky about the fact that if you've spent time building a script for them, they own that script. And you cannot use that script on some other project. Okay. A lot of clients are flexible about that, so that it's your work, you've developed a tool, you can use it across multiple things. But some are very, very specific. Less about scripts, but more about things like HDAs. If you've built an actual asset or a tool for them, they don't want that to be used across other things. So if you ever need to separate them, then you can do it this way. Here is a way of grabbing your global tools and scripts, but you can then do it per project as well in a way of sort of forcing yourself to not use the HDAs from other clients where you would actually get in trouble for doing that. Okay. This is if you're like freelancing or whatever. I mean, obviously, if you're just doing personal projects and stuff, then it's all irrelevant. Then you can just put it all in global locations and have access to all of it. Okay, so I hope that was useful. This is you know, this is kind of the real nitty-gritty type scripting stuff. It's not quite as splashy and fun as what we're going to be doing soon, where, you know, like clicking buttons and creating cool things in Houdini. But it is an important part to know, because if you can have this be created, then being able to just scan your HDAs and scan scripts from wherever you are is going to enable us to do amazing things in the future. All right. Okay, so thank you everyone, and I'll see you in the next lesson.